timing controls. Okay, timing controls provides the way to specify the simulation timing. Okay, the simulation timing is nothing but the while executing the set of inputs will provide them in the form of the test bench. Test bench will be executing lines of code. There will get the give the inputs with the some specified time durations, these we call as what the timing conditions. Timing conditions are the nothing but it's controls the and controls timing controls provide a way to specify the simulation time at which the procedural statements will going to be executed one by one. That's the there are three ways to methods to timing control. Timing control. There are three methods. One is what the first one is what the delay based. First one is what the delay. These are what called as the delay itself. Delay based timing control. Next is what the second is what the event D. Okay, event based timing control, and the L is nothing but the level based timing control. Okay, first one is what the this will provide what the mainly timing control is nothing but the it is provides the to how to specify the simulation time for one inputs. While taking the input, it will to be wait for the few seconds. That delay is called as the timing control. And also there are three ways to specify the timing control. One is what the delay based timing control, and also event based timing control, and the level based timing control. Okay, that's the delay based. First one is what the delay based. Delay based control is nothing but the it is the timing control is an expression specifies the time duration between the time of between the time of for the encountered. It's what the time of encounter. If it's a delay, if it's happening, it's the what the it's the encountering the start time, and also it is what the execution time. This is what the complete execution. Okay, complete execution. There is a some period of time delay is there, some delay is there. This one is called as the delay based timing control. These will be specified explicitly in the expression itself, as with the help of for the hash symbol, as we already studied in the hash symbol. Hash delay like this, hash delay of and the value hash delay value. It means what the if it is we are mentioning the any variable, the any variable or what the any expression or the any values, if the hash with the some value here with the this we call as the delay based. Okay, this is what the delay. We are mentioning the delay explicitly with the numbering, with the timing unit, with the hash symbol. This we call the delay value. Delay value is what we are mentioning here, 5. Even you can give the any number value also, 30, 10 like this. It depends on the what type of timing you are using, whether it is a nanosecond, microsecond. It's most probably the many times the will use the nanoseconds itself. Okay, and in this delay itself we have the three more concepts, three more. One is what the regular delay control. This is the regular delay control. Second one is the assignment delay. Third one is what the zero delay method. You can easily predict that what type of regular method was intra-assignment delay, and also you can easily zero delay. We are not mentioning any delay over here. It means what the we are not giving the delay conditions here, delay conditions. We are not mentioning the elite delay conditions. It means here the delay based timing control itself, we have the regular delay based control timing control, intra assignment delay, and the another one is what the zero delay. Zero delay is nothing but we are not mentioning any delay over here. We will not mention the any delay here. Directly we are giving the variable as the reg equals to reg as a equals to 10. Okay, some values here, a equals to 10 like this. It means here that we are not mentioning any delay here. We are not using the any explicitly. We are not mentioning here. Regular delay method is used only on the non-zero. Non-zero means it's a regular delay ಅಂತ ಇಟ್ಕೊ. Regular delay ಅಂದ್ರೆ it's compulsory delay must be there. Delay must be there. It's we call this for the non-zero. Non-zero ಅಂದ್ರೆ if there is a must be delay is there. There must be some delay is there. This we call it the regular delay. Regular delays are used mainly with the help of for the some initial. You can also treat values as the initial. Okay, let me have the here initial and also we begin the begin will mention the x equals to 0 and also will mention the is explicitly here the 10 y equals to 1 10 y equals to 1 and also we can also mention the some latency will some delay here latency with the some latency also as x equals to z equals to 0 like this we'll have the z equals to 0 and also we can also mention the y equals to x plus of x plus of 1 x plus 1 here we means what the it's a end we can say it's what the end initially within the initial statement we are writing what the behavioral statements behavioral modeling statements we start with the begin and end there we are writing the some what is this statement we call them as for the behavioral model statement we are mentioning here the explicitly the regular delay means what the we don't have the any we are initializing the x equals to 0 there we are mentioning the regular delay it's what the regular delay mentioning and it means what the we are explicitly we are sending the value here the delay here this we call as for the regular delay if you are using the some assignment keywords with the delay value then we call it what the intra assignment delay how these to be mentioned here the intra assignment delay is nothing but the y equals to plus 5 hash of 5 x plus of z this is x plus z is what the one assignment statement is there within this we are sending what the within this we are sending the delay also we call it what the intra assignment delay intra means what inside the assignment this is what the one statement is there inside this statement only we are sending the delay itself we call this for the intra assignment delay and also next is what the zero delay means what the if any we are not mentioning the any delay here directly we are taking the values and all okay usually the if you have the some statement as what the initial and also we are the begin initial and begin is there if you are sending the values here the directly x equals to 0 z equals to 0 and also here the we can make it for the end if you want to have the one more begin and end once again you need to what the initial statement begin and the end begin and end where we will be thinking it's for the 0 it's for the x equals to 1 and also 0 x equals to sorry z equals to 1 it means here that we are not sending any delays here just nothing but what the zero delay itself this is the one way of attending mentioning the zero delay is nothing but the we are not taking any delay here we are not mentioning the any delay if you are mentioning explicitly then also if you are mentioning then also we are sending what the with the hash of for the zero delay hash of 0 if you are not mentioning this is also called as the zero delay if you are sending the delay if you are mentioning the delay itself with the explicitly hash of 0 if you are taking this value as the another value as 1 2 3 that will become sort of the regular delay if you are sending the delay itself as the 0 then we call for the zero delay zero delay can be mentioned in two ways one is for the implicitly as the without any delay mentioning and also if you want to mention the delay itself as the in the statement then you can send the delay with the you can mention the delay with the hash of the 0 this is what we call as the zero delay this is all about the delay based timing control okay once again I want to repeat it okay if you want okay delay based timing control units are nothing but these are the regular delay we'll have the mention the some delay over here we can have the three types of delay here. One, this is what the this delay value is to be mentioned with the hash of for the delay value. Okay, explicitly we are sending the value here the 5 with the this is what the hash symbol. This is what the hash. This is what the delay based timing control. In delay based timing control itself, we have the three phases. One is what the regular delay, another one is the intra assignment delay, third one is what the zero delay. Zero delay. Come to the point where first we consider the regular delay. Regular delay will do what we'll do here. We'll mention the directly mention the explicitly here the some values here, as the regular delay is nothing but the if you can send the any delay with the 5 with the some variables and all some any expressions, we are sending directly. We are mentioning here means what the we before the any variables we will have the delay and all in the regular delay. But intra assignment delay, what we are doing here, we are sending the as a delay itself inside the assignment statement. Assignment statement here we will take the y equals to x plus of z. This is x plus of z manipulation will have the 5 nanoseconds of delay itself here. Intra assignment here mentioning what the regular delay, we are mentioning the as the explicitly as y is having the equals to 1, it is itself having the delay as the 10 year. Like this we will mention latency we are mentioning before the any expression we will mention the delay itself. That will call the regular delay. In the expression itself we are sending the delay assignment delay statement delay. This we call the intra assignment delay. And zero delay, next one is what the zero delay is mentioned. If you not mention any delay over in this one, then these two call is what the zero delay. Zero delay. If you want to send explicitly the delay itself, then you can also mention the zero delay as for the hash of zero. Hash of zero. This one is called as the zero delay. Okay, this is all about the delay based control, timing control. Next is what the event based timing control. Event based timing control. Event based timing control is what the event is to be changed the value register, okay, or net. If any events are going to happen, then definitely for that event we will be changing the register value. Reg value is what the output of the any operation that is to be changing what the value as 0 to 1 also. This is what the event based. And even the on the wires are net, the data will be flowing from the one gate to another gate. That time the event will be happening, okay, that the this net value is from the net output. The output of the any logic gate will have the the output, okay, through what the in the register that we call the reg. And even the output of this one is will be say having the values to be can mention as the net also. Okay, this is what the even some examples we have seen in the last class. That is the counter is having the inputs as the one is what the clock, another one is what the reset. For the clock, usually clock will have the signal as what the positive and negative, positive and negative. How it is to be what the rising edge is called as the positive, and this is what the falling edge is called as what the negative. We can also say is for the like this is also what the signal is there. This is what the positive side, this is what the negative side. And even we can say is for the this is what the falling rising edge, rising side we can for the what is the positive edge. Positive edge, this is what the negative edge. This is what the negative edge. Wherever events happened with the delay will be mentioning here. If the positive edge, wherever the positive edge is there in the signal, that is the there will have the some delay will be mentioning. That we call it the event based. If the positive edge of delay, positive edge of signal is going, wherever the positive edge coming in the signal, the clock in the clock, that will used to be considered as what the event delay. There will can mention the some delay over there. Events are two one. One is what the positive edge, pause edge, pause edge. Another one is what the negative edge. Okay, this is if any positive edge happening in the signal, then the event will be going to change its value to be changed. If any negative, if we have to mention the explicitly, we have to mention the explicitly. Okay, there is the three types. One is what the regular event, another one is the named event, third one is what the event or control. Okay, first one will consider the regular event. Okay, event based also three types. One is what the regular event based control. Second one is what the named control. Third one is what the event or control. Event or control. Okay, event or control. Regular event control, as you all seen in the last class, that is the which is what we are to consider the, there we consider the what is the counter will have the inputs as the for the clock and the reset. Clock will be having the two phase events as the negative edge and even positive edge also. There we have to mention the, for example, if you use any symbol, okay, regular control units will be used the one symbol, that's what the at the rate, at the rate we'll use the this regular based control will have the one that's the at the rate symbol will be using. And also we have the some positive and negative edge. We'll mention here the, if you are using the at the regular based, at the positive edge of, we mention the pause edge. There are two possibilities in the regular base. One is what pause edge, another one is what the negative edge, neg edge. Okay, neg edge. You can mention directly neg edge also. Okay, negative edge also. Okay, even we can also mention the values here, the equal to d. If any value is having the positive edge triggered, there you have to mention the y equals to a also. We can mention the value here with the possibility of having the, for this equality we will have the some event based, there must be some delay over there. This delay is mentioned with the help of what the at the rate of pause edge, that this delay time only it will be going to change the value equals to y equal to a only. The similarly the negative edge clock is nothing but the negative edge clock is equals to q equals to q equals to d. And also even we can also mention the q equals to at the rate of pause edge clock and d. Okay, this is what the d is evaluated immediately. This at this position d is evaluated immediately. The value is to be assigned the whatever the evaluated d value is, what the assigned to where in the equality, that's the LHS part. It means what the, there must be delay, mentioning we are delay as the x equals to 1, y equals to there we are mentioning here. Okay, there we are mentioning the y equals to a can be mentioned as 0, 1, x and z also values here, this possibility. This we can also mention the some values also, x equals to d value can be mentioned explicitly here. Okay, at the negative edge time, this much delay you can have the we can mention here. If you can even you can also mention the d value as the 1, 2, 3 like this, but here the explicitly we are mentioning it. Okay, d equals to some values here, d equals to 1 or 3 like this we'll mention here in the programming in the statement. This we call the at the with the d we are calculating with the positive edge, the values to be assigned to q with the delay only. It means here the wherever the positive edge comes, we should have the this much of delay as the a equals to 1, 2, 3 something. If negative edge comes, q equals to d equals to some values, it should have positive edge at the rate it is having the immediate value of calculation for this d value, okay. The keyword, the negative and the positive edge will be mentioned with the help of for the pause edge for the positive edge, negative edge for negatives. These are the keywords. Full ಬರೆದಿರಲ್ಲ, positive edge ಅಂತ ಬರೆದಿರಲ್ಲ, pause edge ಅಂತ ಬರೆದ್ರೆ ಸಾಕು, negative with negative edge ಅಂತ ಬರೆದ್ರೆ. These are the keywords we'll be using. Okay. Usually the our regular control will be mentioned with the symbol of at the rate symbol, always at the rate symbol. Okay. Okay, next is what the named control. Named control is nothing but this, if any events happening that does not control, that does not be hold for a moment. It is to be what the wherever the names comes to the event, particular event, we can change the named control. If you are giving the names as the name itself as the positive clock. Instead of giving the positive clock, you can also give the some name values also. Last data first bit, and you can mention here like this. One we can also mention wherever you find the last bit, data bit, there we can have to introduce the some delay over there, some delay here, some delay. This we call the named control delay, event control delay, event or control. This will have the, we are using the some multiple values are there, event based. If the multiple values of if you are having these multiple number of values, there you have to mention the inputs as the some delay over there for selecting the two values. If else statement, you know already, if statement ಅಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ, if it is true you come this if statement has to be executed, else if it is a false, you can mention the execute the this second statement. These multiple number of statements are there you can event or control. Event means what? If it is a true, then only it will be execute the first statement, otherwise it will execute the second statement. ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಇದು ಟ್ರೂ ಇದ್ದಾಗ ಮಾತ್ರ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗ್ತದೆ. ಅಂದ್ರೆ ಈವೆಂಟ್ ಆರ್ ಕಂಟ್ರೋಲ್ ಮಾಡ್ತಿದೆ. ಈ ಟ್ರೂ ಇದ್ರೆ ಮಾತ್ರ ಇದು ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡುತ್ತೆ, ಫಾಲ್ಸ್ ಇದ್ರೆ ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡುತ್ತೆ. ದಿಸ್ ವಾಟ್ ದ ಈವೆಂಟ್ ಆರ್ ಕಂಟ್ರೋಲ್ ಬೇಸ್ಡ್ ಡಿಲೇ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಇಸ್ ವಾಟ್ ದ, this is all about the as we all studied the delay based timing control and the event based timing control. Does anybody have the doubts? Okay, I hope it's clear for you all. Okay, next is what the level based timing control. ಲೆವೆಲ್ ಬೇಸ್ಡ್ ಕಂಟ್ರೋಲ್ ಏನಂತ, ಲೆವೆಲ್ ಬೇಸ್ಡ್ ಅಂದ್ರೆ ಏನಿರ್ತದ, ಟೂ ಲೆವೆಲ್ಸ್ ಇರ್ತಾವೆ. ಯಾವಾಗಲೂ ಟೂ ಲೆವೆಲ್ಸ್ ಇರ್ತಾವ. ಯಾವ್ದು ಇರ್ತದ, either 0 or 1. If I mention the 0 level, then the particular statement has to be executed, and also it is to be what the statement enter to the 0 idra not don't execute, event ಇರ್ತದೆ. 1 ಇರ್ತದೆ execute ಮಾಡೋದು ಅಂತ ಹೇಳ್ತದೆ. This what the level based control units. For example, it has the some syntax here. Always wait enables with the delay of what the 20, with the delay of 20, count equals to count plus 1, count plus of 1. It means what the count will be incremented for every one with the level of 1, and also it's every control incrementation will be enabled with the wait. Wait means what the, it's a delay here. Wait means what the delay is, and wait is enabled with the delay of what the 20 nanoseconds. We are mentioning this, we calls for the level based. If the level is what the, if the level is mentioned as the 0 ಇದ್ರ ಏನು ಮಾಡಬೇಡ, ಕೌಂಟ್ ಪ್ಲಸ್ ಮಾಡಬೇಡ ಅಂತ ಹೇಳ್ತಾರೆ. ಒಂದ್ ವೇಳೆ ಲೆವೆಲ್ 1 ಇದ್ರೆ ಮಾತ್ರ ನೀನು ಕೌಂಟ್ ಪ್ಲಸ್ 1, ಕೌಂಟ್ 20 ಇದ್ರೆ 20 ಪ್ಲಸ್ 1, 20 ಪ್ಲಸ್ 2, 20 ಪ್ಲಸ್ ಲೈಕ್ 21 ಪ್ಲಸ್ 1 ಇನ್ಕ್ರಿಮೆಂಟ್ ಮಾಡ. ಯಾವಾಗ ಲೆವೆಲ್ 1 ಇದ್ದಾಗ ಮಾತ್ರ, ಲೆವೆಲ್ 0 ಇದ್ದಾಗ ಮಾತ್ರ ಏನು ಮಾಡಬೇಡ, ಜಸ್ಟ್ ಡೋಂಟ್ ಎಕ್ಸಿಕ್ಯೂಟ್ ದಿಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಂತ ಹೇಳ್ತದೆ. Okay, if it is executing, then you have to introduce the count ಮಾಡಬೇಕಾದ್ರೆ ಆ ಟೈಮಲ್ಲಿ introduce the some delay over there. This one calls the explicitly we are mentioning with the level based control unit, controlling. This is what they will be asking in the examination. Write a timing control for the behavioral statement. You should mention the what is the timing control and all. And there also you have to mention the delay based timing control, event based timing control, level based timing control. There you have to mention what the regular, second one another intra assignments, amela 0 delay. Okay, next you come to the event based regular controller, named control, and the event or control unit. Third one is what the level based ಬಂದಾಗ, level based ಬಂದಾಗ there are two levels, 0 ಮತ್ತು 1. 0 ಇದ್ದಾಗ ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡಬೇಡ, 1 ಇದ್ದಾಗ ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡು. ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಅಲ್ಲಿ there you have to introduce the some delay over there. You explicitly you can mention. This is all about the timing control in the behavioral model. Okay, this is they will be asking in the 8 marks in the examination. Okay, don't worry. Conditional statements are there. Stop ಮಾಡೋಣ.